All right, so now we are talking about solving compound inequalities. So basically solving compound inequalities is basically you have two inequalities that you're solving. So you're going to still kind of solve them separately as two separate inequalities, and then you're going to combine them when you actually graph them. And I know in the last video I didn't go ahead and show the graphing. We'll show it in this video. So for instance, for this first problem here on your left, you're still going to draw your wall like you've done prior, because again, you still want that inequality to be the representation of both sides. On here, only on the left side is the variable, that n. There's only a number on this side. So we're going to go back over here, and we want to get rid of that 2. So I'm going to subtract 2 from both sides. When I do so, I'm left with an n. Again, I drop down my inequality because I didn't multiply or divide by a negative. Negative 5 minus 2 is negative 7. So I'm done with that side. Now I'm going to go over on this other side. I'm going to draw my wall. Again, I'm looking at which side is my variable on. I see it's on this side. There's only a number over here, so I'm happy with that. So again, that plus 6, I need to subtract 6 from both sides of that wall. All right, so both sides of the inequality. When I do so, on this left side, I'm left with an n. I'm going to keep my inequality exactly the same. Negative 6 minus 6 is negative 12. Now, for a final step, where this comes into play, after you've actually done the math, is you're going to graph it. So I'm going to go real simple. I have negative 12 here, I have negative 7 here, and I have a 0 there. How about that? So I know that when dealing with less than or equal to, okay, so when I have the less than or equal to, I'll do my best here, or a greater than or equal to, I have a solid circle. And if I only have greater than or less than, I have an open circle. So here I have both solid circles. So at negative 7, I'm going to put a dot, a solid dot, as best as I can on here. And at negative 12, I'm going to put a solid dot. Now you're simply looking at what's going on. So the left side over here, this problem says n is less than or equal to negative 7. Well, which direction is less than or equal to negative 7? I'm shading that way. Over here on my other one, it says n is greater than or equal to negative 12. Well, greater than is going that way. So since there is the word and right here, I am going to shade simply in between these two. And then I would be done with this particular problem. All right, so this problem is just slightly different, because if you notice this problem compared to the last one, this is the word or as opposed to and. So this is where we're talking about it's going to be one or the other situation. So again, I'm going to do exactly the problem the exact same way I've been doing. So I'm going to subtract 14 because I asked myself which side of the inequality is the variable on. It's on the left side. I need to know how to move stuff. I have a positive 14, so I need to move it to the other side, which is negative 14. I'm left with an x. I drop down my inequality exactly the same. 15 minus 14 is 1. Over here on the second one, I'm going to draw my wall. Again, I ask myself what side of the inequality or the wall is my variable on. Well, it's on the left. What else is on there? That minus 9. How do I move that? I do the opposite. I'm going to add 9 to both sides. Then, what am I left with? I have an x here. I have a less than there. Negative 10 plus 9 is negative 1. So now I'm going to do a graph down here. And again, I go real easy. I have a negative 1. Sometimes I just do this. I have the two values that I need to actually graph. So notice the difference between this one. Right here, I have simply a greater than and I have a less than going on here. I don't have that equal to. So these are going to be open circles. So I'm going to have an open circle here. I'm going to have an open circle there. So you read it. This first problem right here says x is greater than 1. Well, where is x going greater than 1? In this direction. Over here on this other one says x is less than negative 1. Well, where is x going smaller than negative 1? In that direction. So I would shade this way, and I would shade that way. And I always typically shade the arrow at the end to represent that it's going to keep on going. All right, now it looks different. Quite frankly, it doesn't look like two separate problems. It's already put together, which is why we call it compound inequalities, because we can write it together. We could separate it if we want to, or again, the steps are going to be the same, so we can do it all at the same time. This is a problem where, honestly, I would draw two walls. Again, you're drawing the walls where you see those inequalities. Now, again, our philosophy behind solving inequalities or solving equations is what I do to one side, I got to do to the other. So here's a case of what I do to one column, I must do to all columns. So looking at where my variable is right here. I have 7c plus 4. So I want to get rid of that 4. Well, the opposite of that 4 is a minus 4. So I'm going to write it in that column, I'm going to write it in that column, and I'm going to write it in that column. And then I'm going to follow through with the math. So negative 3 minus 4 is negative 7. I'm going to write down my inequality. Now all I have left in here is a 7c because the 4 is canceled. And then I have 18 minus 4, which is 14. So as you guys know, here we are. Again, we're looking back. Where is the variable? The variable is in the middle. What's it currently attached to the variable? That's 7. So to get rid of that 7, I need to divide by 7. Well, again, what I do in one column, I must do in every column. And I'll do this one so that looks easier. So now I'm left with negative 7 divided by 7 is negative 1. Again, drop down the inequality. I'm left with a c here. Drop down the inequality, and 14 divided by 7 is 2. So if I want to graph this, I already have it in a great order here. So I know that. Well, I know this one gives me a solid circle because it was less than or equal to. I know this one has an open circle. And if you notice where that variable is, it's in the middle. So that's where you shade. That's why you shade in the middle, because it's already in between those two. But you could read it as c is greater than, if you look at it this way, c is greater than negative 1, and c is less than 2, and this graph totally does that. All right, so now this problem looks more complex, right? Now you're saying, wait a second, there's variables in every location, and there are numbers in every location. You can do this one of two ways. You can either separate it into two separate problems. So you have 2a, negative 2a plus 3 is greater than 6a minus 1, and 6a minus 1, notice I said the word and there, is greater than 3a minus 10. So I'm going to take out that and there. It's in my way. So now you have two inequalities that, yes, there's variables on both sides, but again, just like old school, you're going to do the wall, you're going to put your variables on the same side together, put your numbers on the opposite side together, and run with it. So for this first problem, I always like positive variables, so I'm going to add 2a to both sides because I don't like a negative variable. That's just my own thing. So my a's on the left side cancel. I'm left with a 3. I drop down my inequality, and I get 8a minus 1. Well, now for the next step, I know that I want that a to be by itself, so I'm going to add the 1 to both sides, so they're happy over there. 3 plus 1 is 4. Keep the inequality, and I have 8a. Well, as you guys know, the next step, I need to get a all by itself, so I'm going to divide both sides by 8. Most common error that I see, this is not 2. This is, in fact, 1/2. So a is less than 1/2. Now I'm going to go over to this side over here on the right side. On the right side, again, I still like my positive a, so I'm going to subtract 3a from both sides. When I do that, over here I get 3a minus 1 is greater than my 3a's canceled, so negative 10. My next step is to add 1 to both sides. So then I'm left with 3a is greater than negative 9. Again, just like before, you guys know how to do this. We're going to divide both sides by 3. And I'm left with a is greater than negative 3. And we won't graph it this time because I ran out of room. But that's the two answers to this problem are right here. A is less than 1/2 and a is greater than negative 3.